Hey guys, so this is another question that I would consider a tricky question, and it's no surprise that it has to do with capacitors. And so just a reminder, and if you're watching our videos chronologically, then you've watched video 7 that shows you how it is that once a capacitor is created and its physical properties are determined, then its capacitance will not be changed. So let me go ahead and let's read through this question. Doubling the voltage across a capacitor will have which of the following effects? So you just said, once the capacitor has been physically created, once you've chosen the dielectric constant, you've chosen the distance between the plates, the area, then the capacitance will not be changed by the voltage. Okay, so that means we can cross out some stuff right away. Let me go ahead and get the red highlighter out. So anything with capacitance would not change. So B is out, and D is out, and then so are E and F because they both involve capacitance. So that means that the charge is somehow changing with the increase in voltage across the capacitor. And in this case, we're doubling the charge, and the answer to this question is actually C. The charge stored on the capacitor will be doubled. And that kind of doesn't really make sense in regards to our equation that we have here, where capacitance is equal to the charge over the voltage. Because if we see an increase in voltage, we either expect to see a decrease in capacitance or a decrease in the charge. But instead, we get a double in charge. So when we increase the voltage, we increase the charge. And so that's, again, because this equation can be used to determine the charge when you know the capacitance and the voltage, but it doesn't necessarily relate the three variables properly, because changing the voltage, again, is not going to change the capacity of the parallel plate capacitor. So why does it make sense that increase in voltage is going to cause an increase in charge? Well, an increase in voltage is an increase in potential difference, or in other words, it's an increase in joules per coulomb. And joules is energy, and then Q is how we measure coulombs. It's our unit for coulombs, in other words, charge. So when you increase the voltage, you're increasing the joules per coulomb, or you're increasing the joules per charge. So it makes sense that by adding more joules per coulomb, you're going to be increasing the amount of energy that's in each charge. So that's why if you were to double the voltage, you end up doubling the charge stored on the capacitor. And I drew this little diagram here because you can think about it as if it was batteries. So let's say you've got this 5 farad capacitor, and then in one scenario you've got 5 volts attached. So you've got a 5-volt battery attached, and that gives you 25 coulombs. Well, I think it would be safe to say that it makes sense that if you were to get a bigger battery on there, now a 10-volt battery, then you would expect to have a greater charge. So you would expect to have 50 coulombs, and that's because now you're adding more joules per coulomb. So hopefully that made sense, guys, and know that capacitors can be tricky, but once you have determined that the properties of a capacitor are the only thing that can change its capacity, then I think it makes a little more sense. So thank you guys for watching. If you have any questions, leave in the comment section below, and we'll do our best to get back to you.